7. Okay. All right, so determining which device is more precise. So I will say you should probably highlight that heading. Here we go. Which device is more precise? It rhymes and everything. Make a rap song out of it. All right, when asked to determine which measuring device is more precise, you have to determine the precision, right? You have to determine the precision of each device. And here's the kicker. I'm going to use a different highlighter for this one. This is basically in a nutshell what you need to show. But the smallest precision tells you which device is more precise. The smaller the increment, the better. Okay? I think you would all have to agree you would want to go with the number that has most decimals. The more decimals it has, or the smaller the markings it goes up by, the better it is. State the precision and uncertainty for each device, then determine which one is more precise. So here we go. You got to pay attention to this to get this right. So remember, you don't just go from number to number, you go from marking to marking. So when there are markings in between, I do this. Either guess, I'm just going to guess, I'm just going to try here. 25 gets you to 75, and then another 25 gets you to 100. So I've actually now determined that my precision is 25. But let's say you did not see what I just did there. Let's say you're like, I need something more concrete, Mr. Erickson. That didn't help me a whole lot. Pick any two numbers here, any two. So let's say you want to make this your low. And hey, you could pick this one up here if you want. It doesn't matter. I tend to just go to the next number, and that's my high number. And then so you use this formula on the side. Watch. I'm going to go precision is high minus low. I gave you this one, divided by gaps. How many gaps are there? Yes. So you go 1, 2, right? Between those two numbers, there are 2 gaps. 2 gaps. So you've got to make sure you do this first, though. Guys, if you go to post-secondary, sometimes they do like skills tests on you. Whenever you have like operations happening either in the numerator or denominator, do those first before you divide. Don't type it all in one shot. You're gonna get it wrong. So this is 50, right? 50 divided by 2, which ends up being 25. And that's how I ultimately mathematically determined that. But you don't have to do it that way. Most of you are just going to look at it and see, oh yeah, it's going up by 25. But sometimes it goes up by something weird, like 7.5. And then you might want to resort to this formula, right? Uncertainty is just 25 divided by 2, which is plus or minus 12.5 of a milliliter. Every measurement has some uncertainty, and so that's what we do. Remember, precision is also known as the limitation of that device. Next, let's do this one. Can you tell what you go up by? Try to give it a wild guess. And I'm just going to go, I'm going to pretend like I have no idea, Mr. Dirksen. I'm just going to use the high-low. Okay? I just need that. So I'm going to go 500 minus 250 divided by, I count 1, 2 gaps between. This is a fail-safe method of doing that. And so you might think, I divide by 2 and then I divide by 3 again. Is it always going to be like that, Mr. Dirksen? 2, 2? No. Sometimes you're going to have 4 gaps, 5 gaps. I don't know. It depends on the scenario. So how about we do, I'm just going to show you, right? This is there. And same here. Just happens to be 2. So 250 divided by 2 is 125 mLs. had to work so hard to... Hi. Yeah. I had to Photoshop all of these. I'll get there. It's all signed. Good to go. Yeah. Photo.
Class after lunch?
No, last period.
Last period?
Yeah.
Okay.
I had to work hard photoshopping these guys because you can't find a lot of examples where students have to like think how much it's going up by, but the province does. So this is my precision, and then 125 divided by 2 is my uncertainty. What is it? 62.5? Okay. Thank you. So there you have, once you have your precision, uncertainty is boom. It's always divided by 2. Always. Let's do the last one here. Oh, I don't know. I'm just lazy, okay, guys? I'm lazy today. I need something that's working every time for me. So from the, what about that middle there, the bigger line that kind of matches? There's, no, you just ignore it. You just go 1, 2, 3, 4. 4 gaps. Okay, so you're going to go high minus low divided by 4. Ooh, you can't see that, sorry. There. So high minus low divided by 4. I like that it came up that it's 4 in this case. And so 60 minus 20 is 40. Over 4 is 10. So that is my precision. The 10 mLs. Uncertainty is 10 divided by 2, which is plus or minus 5 mLs. I told you the plus or minus is optional, right? The province won't mark it wrong if you don't have the plus or minus. Just make sure, don't put it in front of the precision because then they will mark it wrong. It only goes with the uncertainty. I say they will mark it wrong even though I mark it, but they tell me that I have to mark it wrong. So there you go. Now, let's zoom out. Which one is the more precise? 25 mLs, 125, 10. 10 mLs is the more precise. So I'm going to use orange, right? Orange shirt day is tomorrow. So let's do it today already, right? So that's the more precise, smallest precision. Most precise, right? Smallest precision, smallest precision. Please do it that way. Figure out your precision, don't guess. Some students make it a guessing game. I don't want you to guess. Okay. Now, I want you to try the same thing down here. I'm basically asking you this, guys. Which one of these 3 readings, right, had the most precise thermometer to measure that temperature? You know how to get your precision and uncertainty off of a number. I hope at least at this point. So come up with the precision, come up with their uncertainties, and then determine which one was most precise. So go for it. 0 risk. You get it wrong, nothing is going to happen. You're just hopefully going to learn. That I would like to happen. Okay. So figure that out. I don't want to take too much time for this, but you go try it right now. Okay. Thing about risking and getting it wrong, perhaps, but then you learn. Okay. There's something about putting it on paper. Okay. Precision 0.1 degrees Celsius because I focus on that one. And therefore my uncertainty is 0.05 degrees Celsius. Okay. My precision here goes to that second decimal, so 0.01 degrees Celsius, right? So there should be 2 decimals, just 1 decimal. So this is 0.005 degrees Celsius. This, guys, the uncertainty is really not necessary for this to answer this, but I don't want you to forget how to do the uncertainty. The precision here is what? 1 degree Celsius, just a whole degree. Like it cannot go anything in between. It's either 16 or 14. That's what we're assuming when it's like this. So this would be plus or minus 0.5 degrees Celsius. So which one is most precise? This one. Oh, I'm going to use orange. So the device that was used to measure Winnipeg's temperature is the more precise because of the lower precision. Okay, let's keep going. There will be more of this down the road, so just heads up for that. I just want to do one more concept today before we go home. Go to 17. 17. There were a bunch of questions I assigned along the way. The keys are still up. And so I just want you to make sure you pay attention, okay, guys? State the maximum and the minimum. So I will introduce a new concept here. Building on what we have, right? Once we state a measurement, once we state as measurement plus or minus uncertainty, we're actually saying that a measurement can be above, it could be a max or below the target measurement. So in general, this is important here. In general, this is how we get our max, like our max and our min. So we're saying when we make a measurement using a device, we could be slightly over what we think we measured, or we could be slightly under what we think we measured. So there's a possible max, there's a possible min. When pop companies fill that can with 355 mLs, it could be a little over, or it could be a little under. They know that, and that's just how it is, because there's a restriction on the device they use. So let's see here. The thermostat in Mr. D's classroom is set to 72 degrees Fahrenheit. There it is. I want you to state this measurement plus or minus the uncertainty. I want you to state it in this format. State it in that format. How do you do that? Find the precision first. Find precision and uncertainty first. Okay, when I ask you to do that, you need to find the precision and the uncertainty first. So let's go ahead and do that. The precision, what's the precision in this case? If you just see the 72, 1, uno, right? 1. So the precision is 1 Fahrenheit. The uncertainty is 1 divided by 2, which is plus or minus 0.5 degrees Fahrenheit. That's your first step. And now you write the measurement with its uncertainty. Now you say the temperature is, watch this, 72, what you already knew, plus or minus 0.5 degrees Fahrenheit. This is what they're asking you to do. So literally, guys, we take it one step further. You already know how to do this part, but you just added this to, you tack this on after the measurement. Okay? And you're like, what about the precision, Mr. Dixon? It was necessary to get your uncertainty, but it wasn't really used, right? Other than finding the uncertainty. So I'm just going to say, hey, this came here, right? That is what we did. And so that's just one step further. I won't forget because it's not the end of class yet, but thank you for reminding me. I promise I'll just finish this page and then I will assign you a question to try, and then that'll be it for today. All right? State the maximum and minimum temperature in the room. I will say this: possible max and min. That's really what it's saying. Like, hey, what's the possibility? Like, what's the highest it could be? What's the lowest it could be? And it's actually not that bad. Think of it. The maximum will be 72 plus the uncertainty. So 72.5 degrees Fahrenheit. And what's the minimum? Right. Take away the 0.5 because it's asking you, right? Minus. So that's 71.5. Sorry, I know. 69.5, right? No. 71.5. I was right. That's right. 71.5. So highest possible, lowest possible. That's all, right? So really what we did today is state our measurement with the uncertainty. That's what they're going to ask you to do quite often. And then from that, we determine the min or the max. So I will just maybe highlight the fact that we're just adding and subtracting the uncertainty. So question, if Mr. D has plants in the room, I don't have them this year, but I used to have, in the room, and the room needs to be at least 65 degrees Fahrenheit. Would it be a good idea to set the thermostat to exactly 65? Because we know now it could go as low as 64.5, right? So explain using your knowledge of precision and uncertainty. So we're going to explain that, okay? Mr. D should not set the temp to 65 since there is a 0.5 degree Fahrenheit uncertainty. Okay. The temperature could fall as low as 64.5 Fahrenheit at that setting. That's all. You're basically saying, hey, I know something that Mr. D maybe doesn't know. I know there's some uncertainty with that thermostat. So in order to ensure that it doesn't go at all below 65, I would probably want to set it to 66, right? Before I leave, set it to 66. Even though that's all automated, it does its own thing. But if I had to, this is what I would do, okay? So this is on page 17. So I want you to try page 20. Okay, so try page 20. That's it for today. You try page 20. So you might have to do a reading actually and read the temperature yourselves and go from there.